Solving systems by elimination. Recall that the standard form of a linear equation is ax plus by equals c. The x and y variables are on the same side of the equal sign and they equal a constant. When both linear equations of a system are in standard form, the system can be solved by using the elimination method. The elimination method or strategy adds or subtracts the equations in the system to literally eliminate a variable. The variable will go away. Now, in order to do that, we have to use additive inverses. So let's talk about what's happening with these expressions. We have -5 plus 5, 6 plus -6, negative 7x plus 7x, 11x plus -11x. What are all of these expressions going to equal? All of these expressions will have a sum of 0. You have to think, why is that happening? What is causing them to have the sum of 0? Well, it's because the expressions are opposites. You have one expression is negative, while the other is the same exact expression but positive. -5 and +5, +6 and -6. -7x, even if we introduce a variable, as long as it's the same exact coefficient and variable, one's just positive and one's negative, when you find their sum, that will equal 0. And then a positive 11x and a negative 11x. Again, the sum of additive inverses are 0. Or the sum of inverses are 0. That's why they're called additive inverses. They have that special property. So we can use that to our advantage because it's almost like these expressions have eliminated. They've gone away and they just have a value of 0. So when you have a system and you're asking how do you decide which variable to eliminate, you first look to see if one variable has the same or opposite coefficients because you can create those additive inverses. So if so, you want to eliminate that variable. So let's look at what that would look like. So if the variables have the same coefficient, you would subtract the two equations to eliminate the variable. So let's say the same coefficient, we had 3 and 3, so 3x and 3x would be the expressions. And we're subtracting because if we have 3x minus 3x, it becomes 0x. The x term eliminates. And here's an example if the variables have opposite coefficients. So here we have 3x and -3x. Now there's opposite signs. We would add the two equations to eliminate the variable. So because if we add 3x plus -3x, then that gives us 0x. Again, the variable eliminates. So now let's actually look at an example from the beginning where we're asked to solve a system by using elimination. We have the system of 6x plus y equals 46 and -5x minus y equals -35. Those two equations are in standard form. The x and y variables are all on the same side, and in fact, you can see that the x and y variables are all lined up nicely to compare the x's and the y coefficients. So the first thing we need to do is choose which variable we're going to eliminate. And if you look at the system, we're choosing the variable y because the y in both equations have opposite coefficients. You have a +1 and a -1. So that will be the easiest variable to eliminate because if we then add the two equations, if we add 6x plus y equals 46 plus -5x minus y equals -35, you're just kind of adding column by column. We'll have 6x plus -5x is 1x. Y plus -y is 0y. So you can see now there's no more y's. It's eliminated. And 46 plus -35 is 11. So since the y variable eliminated, we've just solved that x equals 11. Now finally, we can substitute that value we just found into either equation and solve. So we're taking x equals 11 and we're substituting it into the equation 6x plus y equals 46. So then we'll solve for y. 6 times 11 is 66. And subtracting 66 from both sides, we get that y equals -20. So then the solution would be the combination of the ordered pair x comma y. So it would be 11 comma -20. And of course, we could always check that solution to be 100% confident with our answer to make sure we didn't make any mistakes by substituting in that x and y value into the two equations and make sure they produce a true statement. And you can see substituting in the first equation, we get 46 equals 46. That's a true statement. And substituting in x and y into the second equation also produces that true statement. So the solution is checked, and we're now 100% confident that that's our answer. Let's try one more. So here we have solve the system by elimination. We have 3x plus y equals 12, and negative 3x minus 3y equals negative 24. The system has both equations written in standard form. So using elimination, our first step would be to find which variable are we going to eliminate. Are we going to eliminate the x's or the y's? And think about how you answer that question. Think about looking at the coefficients. You want to find those opposite coefficients or the same coefficients. In this example, we're choosing the x to eliminate because the x in both equations have opposite coefficients. You have positive 3 and negative 3, so that will be the easiest to eliminate. We can automatically add the two equations, so 3x plus negative 3x eliminates. It's 0x and goes away. That leaves us with 1y plus negative 3y is negative 2y, and then 12 plus negative 24 is negative 12. So now we just have to divide both sides by negative 2, and we get that y equals 6. That's half of our solution, so to find the other half, we need to find the value of x. So we'll substitute in y equals 6 into one of our equations, it doesn't matter which one, and solve for x. We're choosing to substitute it into 3x plus y equals 12, except it's not y anymore, it'll be plus 6. So then we'll subtract 6 from both sides, we'll get 3x equals 6, and dividing both sides by 3, we get that x equals 2. So if y equals 6 and x equals 2, our solution to this system is the ordered pair of x comma y, so it will be 2 comma 6. And when we check that solution by substituting it into both equations, it produces a true statement. So that means it checks out and it is true. And it is a solution to the system. It's a solution to each equation. So we've solved using elimination. Remember the whole goal of elimination, why this was really easy is because this system had opposite coefficients for a variable. And the equations were written in standard form. So you want to be on the lookout for those things when solving.